Welcome all. In this lecture, we are going to study about total internal reflection. But before study about the total internal reflection, we should have a look at the three phenomena, that is reflection, refraction and then critical angle. And after studying the three phenomena, we will study about the total internal reflection. So let's have a quick review about the reflection first. So what do you mean by the reflection? See, reflection is defined as a phenomena in which when a ray of light incident on a smooth polished surface, then it will get bounces back into the same medium. And this bouncing back phenomena is defined as a reflection. So here is a smooth polished surface and this is the incident wave which get incident on this smooth polished surface, and it makes an angle of theta I with this normal. Since this bouncing back phenomena happens at this point on the smooth polished surface, that's why this incident wave will get reflected in this direction, making an angle of theta r with the normal. And this phenomena is known as reflection. Now let us have a look at the laws of reflection. So basically there are two laws of reflection. Moving on to the first law, it says that the incident ray, that is this, and the reflected ray, that is this, and the normal, that is this, all will lie in the same plane as you see in this diagram. That is incident wave, reflected wave and the normal all are lying in the same plane. So it follows the law of reflection number first. Also, according to the second law of reflection, the angle of incidence should always be equal to the angle of reflection only. If we mathematically discuss this law, then it means that the value of theta I should always be equal to the value of theta r. That is, theta I is this angle and theta r is this angle. So theta I should be equal to theta r, and this is all about the phenomena of reflection. Now let us have a look at the second phenomena, that is refraction. See, refraction is defined as a change in the direction of wave which is passing from the one medium to the another medium. So here is a wave that is passing from the rarer medium to the denser medium. So there is a bending of light that occurs, and it refers to the bending of light which is caused due to the change in the density of the medium. So since it is a rarer medium, so it is having the less density as compared to the denser medium. That's why here is a bending of light that occurs. And also if we talk about the refraction, then there are the two cases. According to the case number 1, when the ray of light travels from the rarer medium to the denser medium. So if the ray of light here in the rarer medium and it is traveling towards the denser medium, then it will bend towards the normal. So it will bend towards the normal. But if we talk about the case number 2, that is when the ray of light that travels from the denser medium towards the rarer medium. So let's suppose this is the denser medium and here is the rarer medium, and if the ray of light, that is this light, is traveling from the denser medium towards the rarer medium, then in this scenario it will bend away from the normal. See, here is the normal, and this ray of light after the reflection bends away from the normal. So away from normal. So these are the two cases that are associated with the phenomena of refraction. So this is all about refraction. Now let us have a look at the third phenomena, that is critical angle. So the critical angle is defined as an angle of incidence for which the angle of refraction is equal to 90 degree. So let's suppose this is the incident ray, and after getting the refracted it is being refracted, making an angle of 90 degree, and this is the angle of incidence, that is theta I. So according to this phenomena of critical angle, we can say that this theta I is known as critical angle. Why it is considered as a critical angle? Because at this angle only the angle of refraction is equals to 90 degree. So this is our refracted wave and this is our normal. And this theta I can also be represented as theta C, where C represents the critical angle. And it is all about the critical angle. Now let us have a look at the final phenomenon, that is total internal reflection. So the total internal reflection is defined as the angle of incidence when being greater than the critical angle, then the wave get totally reflected wave into the same medium. So when the angle of incidence is greater than critical angle, then in this condition we can say that the wave get totally reflected back. Into the same medium, into the same medium. And this phenomena is known as total internal reflection. Let us understand this phenomena by the diagrammatic representation. So here is the normal and here is the incident ray that makes an angle of theta I with the normal. So this is the normal and this is the incident wave that makes an angle of theta I with the normal. According to the phenomena of total internal reflection, it will get totally reflected back into this same medium, making an angle of theta R in this direction. Okay. Now there are two conditions that are associated with the phenomena of total internal reflection. So the conditions are: if we talk about the condition number 1, then it says that wave should travel from the denser to the rarer medium only. That means that this medium always be a denser medium from which the ray get incident onto the normal, and this should be a rarer medium. So wave should travel from denser to rarer medium. And if we talk about the second condition, then it says that the angle of incidence, that is theta I, should always be greater than the critical angle. So angle of incidence that is represented by theta I should be greater than critical angle. And it is represented by theta C that we discussed earlier, that is here, because at the angle of incidence that is equals to the critical angle, the refracted wave makes an angle of 90 degree. So for the wave to be reflected back into the same medium, this angle of incidence should be greater than this critical angle. That's why this wave gets reflected into the same medium. And this is all about the total internal reflection. If you like my videos, then do subscribe my channel and please hit the like button. Thank you.